Okay, it sounds like some people have come up with some answers, so let's see if we can handle this all right. So, to start with, what substitution did you make? Uh-oh, nobody got started? What substitution did you make to start? What change did you make? Sure, so I want to get rid of this half x, so one strategy would be, let's make a substitution. Okay, so if I said let theta equal 1/2 x, then my equation has now become cosine theta equals -√2/2. And I mentioned this, but we're really talking about that piece. So maybe I'll just make a quick change. It's just the rationalized form. But okay, now we have the substitution, and the equation looks friendlier. We also need to update the range. It's no longer from 0 to 2 pi. Okay. This time, we need to make our change, so what would x be equal to? Two thetas, yeah. So from that equation, I get x is equal to 2 thetas. So 0 is less than or equal to 2 theta is less than or equal to 2 pi. If I divide everybody by 2, then I'm going to have 0 is less than or equal to theta is less than or equal to pi. So now I have a different domain and my new equation. So I followed the same set of rules that I was given. I have a new equation to do it with. Okay, so if cosine is negative, that means I would expect to find it in these quadrants. The reference angle is pi over 4. So my possible answers would be 3 pi over 4 and 5 pi over 4. Okay, so what do you think of that? Why not? It is. So that's a good observation. The range had to be stopping at pi. So that means down here, I have to reject that. It's too far out of range. The only one that if I'm playing by the same rules, this is the only one that works in that set of values. So I have one answer that says theta must be 3 pi over 4. Okay. So what would I get then if I was to get my answer back in terms of x? Yeah, timesing it by 2. This is the relationship, so I have to times by 2. That means x will be 6 pi over 4, which we'd most likely write as 3 pi over 2. Okay, so one thing that I want you to notice about this as well is we should double check that this actually makes sense. So here's how we double check. The one answer that worked for us in the equation that we solved right here was this one. If I was to take 3 pi over 2 and put it up here, when I half 3 pi over 2, where do I end up? 3 pi over 4. See that? When I put it back in, I end up halving it, and that gets me right back to the answer I found. So I can check that I've made the right conversion. Same thing over here. If I put in, these are the answers that we worked out. Okay, if I put in 4 pi over 6 and I double it, that means I'm going to be at 4 pi over 3. So they do line up. 10 pi over 6, if I go around here and I put it in for x, that becomes double, which becomes 10 pi over 3. So every one of these answers lines back up to the original. That's how we know we've done this conversion properly. Okay, I realize you may need a little bit more practice on that. If you do want to go over some more of those style questions, then just stick around at lunch today when we finish off. Okay, so the last thing we have to talk about is not really, well, there's two things, I guess, but it's not really solving any particular equation, but it's the general solution. We talked about this for finding asymptotes. We should also talk about it for finding trig solutions. Okay, so do you remember what was the solutions to this equation that we started with? It's on your sheet. You don't need to go and resolve it. It's up, I think it was the first one we did. Can somebody give me those values? Sorry? No, it's the very first one we did. The very first one.
Very first one? Like secant x equals -.
Okay, I'll just scroll up then. How about that?
So cold.
Okay, so here's the first one that I'm referring to right here. Those were the two answers, pi over 3 and 5 pi over 3. So for these next couple examples, I'm not interested in you doing the solving again. We just want to look for the general equation. So this was pi over 3 and 5 pi over 3. Now when we look at this graph here, what will we end up having for the period of that, if we were to think about it as a graph? How often does that graph repeat? Well, what's the normal period for a cosine graph? 2 pi. Has anybody mucked around with the horizontal stretch factor here? So what should the period be? 2 pi. So that means 2 pi, these answers repeat again and again and again. So if I was to add 2 pi and go 360 degrees around, then I would find myself right back there at pi over 3. If I was at 5 pi over 3 and I moved by that same amount, I'd be right back there at 5 pi, well, that would be 11 pi over 3. And it would keep repeating. So to find the general solution here, we would come up with pi over 3 plus 2 pi n and 5 pi over 3 plus 2 pi n. And of course we have to say n is an integer, just so we're clear. So we know the answers to these next 5 questions. I just want you to try to talk about what the general solution would be, and I would like you to do it for the first 3. Okay? We'll talk about the next 2 together, but try it for the first 3. Just write down what the general solution should be. Okay, so I need to borrow somebody's, let's see here, Alex, let me borrow your, actually somebody have a printed copy? I just want to get the notes off the top of it. Any printed copies? Thank you, I just wanted to get the solutions. So the first solution is going to be, it was 7 pi over 6 and pi over 6, so I promise I'll give it back, I just want to write this down. And this would be 7 pi over 6. The next one here was 3 pi over 2. And over here, let's see, pi over 6 and 7 pi over 6 again. Oh, sorry. It was pi over 3 and 4 pi over 3. Okay, does that line up okay? Have I written them down properly? Yes, ma'am?
5 pi over 6.
5 pi over 6. Okay. So this time, what we're trying to figure out is how often it repeats. So in this case, the secant graph, it repeats every 2 pi. Okay, so it'll be plus 2 pi n and 2 pi n here. Okay, in this graph, the sign repeats every 2 pi, so it'd be plus 2 pi n. And then finally, pi over 3, 4 pi over 3. The tangent has a period of pi. So we could write it down like this. Now, one thing that may be helpful to you is to take a look at what's redundant. If we look at this picture, this is what it looked like. Pi over 3, 4 pi over 3. So one thing you may notice here is when I go from pi over 3, I actually land on 4 pi over 3. So this piece is actually redundant. I don't need to record it. It's already included from the first answer. Okay? So every pi over 2, this one is repeating. Whereas if we were to look, the other ones, it makes sense because this one here it ended up being a negative. I was looking in these two quadrants. I actually have to go all the way around, and then I hit the next one. I don't actually line up nicely like I did with the tangent graph. Okay? So sine 2x, we had quite a few answers for this. But the ones that actually counted were the ones that were down here. The other ones were just a coterminal examples, I believe. Let's just see what... I'll have to refresh my memory here. What were the 4 answers? So 2 pi over 3, 5 pi over 3. Let's see if I can remember this. 2 pi over 3, which will be... So 2 pi over 3 is here. So 2 pi over 3. Then I had 5 pi over 3, which would be here. The other ones were, let's see here, 11 pi over 6 and 5 pi over 6. So they would actually be in there as well. So there'd be like 5 pi over 6. Sorry, so that's 2 pi over 3. And this one here would be, say, 5 pi over 6 and 11 pi over 6. So like the graph we already talked about, if I go from 5 pi over 6, if I go over by pi, I start doubling up. So it's going to be redundant again. So that means I don't need to write out all 4 answers. If I started at 2 pi over 3 and I moved by pi, I would land there again as well. It's also redundant. So the only 2 that I actually need are these ones here, 2 pi over 3 and 5 pi over 6 plus pi n. Can someone make sense of it for us? Why is it pi n now and not 2 pi n? Aside from the fact that we just did a picture that kind of shows it only repeating every pi. Yeah, now we have a horizontal stretch factor right here, which changes this to a half. So a half the normal period of 2 pi. That's why we're now sitting at pi. Okay, apparently there's a typo here. That should be a 2. Okay. So this one was nice. There was only one answer. Do you remember what it was? 3 pi over 2? How often will it repeat? Every 4 pi. That's right. So it'll be 4 pi n. Okay, so that's how we do a general solution to our equations. Typically, if this is added to the written section, the equation is worth 3 points, and the general solution worth 1 more. Okay, so 1 more to be able to do that skill. It's not a bad trade. Okay, so you need to grab your graphing calculators. You don't have them out just yet.